Hi, today I'll be sharing more about our project Punggol Pathfinder. So for the content, it will be split into 3 portions. First will be the guide on how to use our application. Second will be how our data is being collected. And lastly, what data structure and algorithm are used to compute our shortest path. So here's how the application looks like, and this is done through using Flask. Firstly, users are able to choose their mode of transport. For the starting location, it will be fixed at Punggol Station, and for the end location, users are able to choose based on the drop-down list given. Before pressing on the submit button, we can see over here the route has been computed, and this shows the faster route to get to the desired location. Upon pressing the submit button, the shortest route will be computed. Over here, we can see that the shortest route is being computed in the text form. And to scroll down, we are able to see it computed in a map form. And over here, user can follow the direction to go to their desired location. So over here, you can see that there's one more tab that is called Plotty Flask. So when you click on the tab, it will show that this is the network graph for the data that we have collected. And by hovering over to the nodes that is plotted in green, it will tell you that if this is a starting point or the ending point. And if you zoom in, you can see that the address will be given. So now I'll be showing you the other 2 modes of transport. So now I'll be showing you the bus. And these are how they look like. And now I'll be showing you the working. So now we'll take a look closer into the map. So in our GUI, it's seen that there are 2 maps which consist of the Google Map reconstruct the fastest route and the OpenStreetMap reconstruct the shortest path to the desired location. So the reason behind it of having 2 graphs is to allow users to compare and decide which route would be better for them at a point of time. So now we'll move on to the network graph. So in the GUI, we will realize that there's an additional tab that opens up called plottyflask.html whenever we click on the submit button. So the plotty flask is used to show our network graph. And our network graph has 3 types, which are sparse, LRT, and working, based on the data we collected. So for the network graph, if the mode of travel is sparse, this will be how it will look like. And so if the mode of travel is LRT, and this is how the graph will look like. And lastly, if the graph is walking, this is how the graph will be look like. So now we'll move on to data collection. So for data collection, there will be 3 types, which are sparse, HTB, and LRT. So for the collection of sparse data, is extracted from data more. And we use HTTP to request the data. And we'll store the data into a JSON file, and after that, the data will be read from the JSON file. For HTB, data is collected from data.world, and data will be stored in a CSV file and also be read through a CSV file. Similarly, for the LRT, data is also collected from the data.world, and data will be stored in a CSV file and read from a CSV file. So now we'll move on to data structure and algorithm use. So for data structure, we are using Python list collection. And we use Python lists for the initial storing after filtering. And reason being is that lists are dynamic and suitable for storing unknown numbers of data. And for the network graph, lists are also used to store the edges. So by doing a for loop, we're able to create the nodes and edges out for the network graph. And for algorithm, we'll be using the Dijkstraat algorithm, as Dijkstraat computes the shortest path. And Dijkstraat uses a priority queue to greedily select the closest vertex that has not yet been processed, and perform this relaxation process on all of its ongoing edges. Thank you.